All right, so we have reached the level 4, and we have a pair of points here. But we don't know the y value of this second point. But what we do know is we know the slope between these 2 points. So what we could do is we can use the formula m is equal to y2 minus y1 all over x2 minus x1. I'm going to put my slope in for m, and then let me label my points x1, y1, x2, y2. And I'm going to do y2 minus y1 all over x2 minus x1. And so I have a 3 equal to, and I'm going to simplify the denominator. So we would get a y minus a 3 all over a 5 minus a 4, which is a 1. All right, well, now we're going to solve this equation for y. So I have a 3 is equal to, and a y minus 3 divided by a 1 is just a y minus 3. And now I'm just going to add 3 to both sides to get y by itself to find out that y is equal to 6. All right, same thing with number 2. I have 2 points. I'm going to label x1, y1, x2, y2. So now I'm going to do the slope formula, y2 minus y1 all over x2 minus x1. And I'm going to set that equal to my slope. However, I am going to assign the negative to either my numerator or my denominator, but not to both. If I assign the negative to the numerator and the denominator, that comes out to be a positive 5/2 slope, which is not what we want. So it does not matter where you assign the negative, but you just cannot assign it to both. I'm going to assign it to the 5. All right. Simplifying the denominator of my first fraction, I would have the following. Oops, sorry, not 15. Negative 5. Okay. Now, you guys should recognize this as a proportion. And with proportions, we use the cross products property to multiply these and solve. So I'm going to take the numerator of my first fraction, multiply it by the denominator of my second one. So I wind up with an 18 minus a 2y is equal to, and the denominator of my first fraction multiplied by the numerator of my second is a positive 10. I'm now going to subtract 18 from both sides to get a negative 2y is equal to a negative 8. Dividing by negative 2 on both sides, I get y is equal to a positive 4. All right, moving on to number 3. Number 3 is a little bit tricky, but we'll get through it. I'm going to label my first points x1, y1, my second point x2, y2. Using the slope formula, I have y2 minus y1 all over x2 minus x1. Now we have an undefined slope. An undefined slope, again, means that 0 is in the denominator of your fraction. It does not matter what's in the numerator. The numerator can be any number in the world. So it does not matter. So I'm going to label it just as a question mark. It does not matter what that number is. So actually, if my numerator was negative 3, that would match the numerator on the left fraction. So, in order, since the numerator is on my left and right fraction now match, because it does not matter what my numerator of my second fraction is, now we must get the denominators of my first and second fraction to match. Well, what value of x would make it so the first denominator is 0? Well, how you would figure that out is you would just set the denominator of your first fraction equal to the denominator of your second fraction, and then you would solve for x. X would need to be a value of 3. All right, moving on to number 4, same type of deal here. Slope formula is y2 minus y1 minus a negative 2 is really a plus 2, all over x2 minus x1, and this should be equal to negative 2. I'm going to simplify my numerator here, so I have a 7 is equal to a 6 minus an x, and that would equal negative 2. We can make this into a proportion if we wish. We can write the number negative 2 as negative 2 over 1. And that easily makes this into a proportion that we can now solve by cross-multiplying. Multiplying the numerator of my first fraction by the denominator of my second, and the denominator of my first fraction by the numerator of my second, we get this. Adding 12 to both sides, and dividing by 2 on both sides. We get x is 19/2. All right, looking at number 5, we want to know, do these points lie on the same line? How do we know if they lie on the same line? Well, if these points lie on the same line, that means that they create a straight line, which would mean that all of these points are solutions to a linear equation, meaning that all of these points, if they fall in the same line, then they must have the same exact slopes between them. So we need to find the slope between my first 2 points. y2 minus y1 over x2 minus x1. I get a slope of negative 2/4, which is a slope of negative 1/2. So that's the slope between the first 2 points. Now I'm going to find the slope between the second 2 points. So y2 minus y1 all over x2 minus x1. We get a positive 1/2 slope. So since the slope between the first 2 points is not the same between my second 2 points, oh, I apologize. Whoa, 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 5 minus a 3 is a positive 2. Ooh, we do have the same slopes. So since the slopes between my first 2 points equal the slope between my second 2 points, these are on the same line because the slopes between all 3 points are the same. I was just keeping you on your toes for that problem. All right, number 6, we want to write the equation of a horizontal line that passes through the point 4, 6. This point 4, 6 means that this is a solution to your equation of your line. So since it's a solution, this is an x and a y value. Horizontal line means your slope is 0. Let's go ahead, let's write this in point slope form. Y minus the y value is equal to your slope of 0 times x minus the x value of this point. And then now what happens is we get y minus 6 is equal to 0 times anything is just 0. And then now isolating y, we get the equation y is equal to 6. Which you already should know that this is a type of horizontal, or this is the type of equation you get with a horizontal line, because if I go all the way back to, what problem was that? If I go all the way back here to problem number 4 on level 2 video 2, we see that when you have y is equal to a number, you get a horizontal line on the graph. So that's why it makes sense that if we have a horizontal line on the graph, we would wind up with an equation that is y is equal to a number. And in fact, that number that you all would wind up with is what y is equal to on the point that was given to you. All right, number 7, we want to find the x and y intercepts of the following equations. Well, the y-intercept is quite simple because, hey, guess what? This is slope-intercept form. Your y-intercept is already in there. So your y-intercept is the point 0, 6. I recall teaching you guys or saying multiple times throughout this unit that when we're finding a y-intercept, your x value is 0. So if you're finding a y-intercept and your x value is 0, then what do you think your y value will be when we're finding an x-intercept? You might have guessed it, your y value would be 0. So what we're going to do to find the x value is we're just going to put 0 in for y in my equation, because y should be 0 when we're dealing with an x-intercept. And now I'm going to find my x-intercept by solving for x. And I get x is 2, so my x-intercept is 2, 0. That brings us to the end of the level 4 video.